So these are the problems that you should have done on your own. Let's go ahead and go through them. This is 6 to the 11th. That's a funny looking 11, but that's what it is. It's 6 to the 11th divided by 6 to the 5th, which is 6 to the 11 minus 5, or 6 to the 6th power. This here is negative 4 to the 9th divided by negative 4 squared, which is negative 4 to the 9 minus 2, or negative 4 to the 7th. We're going to combine rules on this one. And so the first thing we need to do is 9 to the 4th times 9 cubed. That is 9 to the 4 plus 3, because I'm multiplying those together, so I add the exponents. So that's 9 to the 7th over 9 squared. And now we'll do the division, which is 9 to the 7 minus 2, or 9 to the 5th power. And finally, we're multiplying these two things together, right? There's a multiplication thing there. This is a whole number. We're dividing by 1. So when I multiply these, it's y to the 8th over y to the 5th. And then continuing on with our rule, we get y to the 8 minus 5, which is y to the 3rd. Boop, boop. And we're done. If you've got any of these wrong, make sure that you are coming to me asking a question. Make sure you are on track with what we're learning this lesson. If you're fine, let's go ahead on and move on to the next examples. The next example is what we call power of the quotient. And what this one states for us is that when we have a fraction, some kind of fraction, a to the b, like that, and inside of the parentheses is this fraction with a power on the outside, any power. We're going to call this to the 5th power. What this is doing is saying we're taking a over b times a over b times a over b times a over b times a over b, and that's really boring to say and do a lot. I don't want you to write all these out, and I don't blame you for not wanting to write them out, because that is a lot of work. So instead, let's use the rule to shorten that work for us, right? What's happening in the numerator? It's a times a times a times a times a, right? That's a to the 5th. And what's happening in the denominator? That's b times b times b times b times b. That's b to the 5th. So what truly happened here? We have the a to the 5th and the b to the 5th both being, we have the a and the b both being taken to the 5th power. So general rule here is that a to the let's call it m over a to the n to the let's call it the p power is going to be a to the m times p over a to the n times p. In other words, whatever variable, whatever power we have here, we are multiplying these things over, right? Remember, this was a 1 and this was a 1. So this is a to the 1 to the 5th power, b to the 1 to the 5th power, 1 times 5, right? So there's our power of a quotient rule. Whenever we have a variable fraction inside parentheses with a power on the outside, the power goes to both the numerator and the denominator. Let's do some examples. So direct application of our rule here. This is the 3rd power going to both numerator and denominator. That's x cubed over y cubed. Here we have the squared going to everything here. Now notice this negative sign makes things a little bit tricksy. This could be a -7 or a negative x, but either way you do it, what happens when you multiply a negative by a negative? It becomes positive. So this is 7 squared over x squared, which we might call 49 over x squared, just because 7 squared is an easy one to do in our heads, right? Notice how, though, this is positive. Because the negative is inside the parentheses, it became a negative times a negative, which made it a positive. Part C here is pretty fun. There's a lot going on in this problem. We need to do the numerator to the 3rd power, and we need to do the denominator to the 3rd power. Let's do this in a couple of steps so we see what happens. We're going to take the numerator to the 3rd power, and we're going to take the denominator to to the third power. Notice how I put those in parentheses, because this is going to bring us back to a rule that we learned in the last lesson, which is our power rule. A to the m to the nth power is a to the m times n. And if we have two things in the denominator, or excuse me, in the parentheses, we have a to the n, b to the n, because the power is going to go to each of these things being multiplied. So what's happening in the top? That's 4 cubed times x squared cubed over 5 cubed times y cubed. Now we got to do a little more simplifying because we have a power to a power here. 4 cubed x to the 6th, because that's 2 times 3. And then this is 5 cubed y to the 3rd. Again, we could go on and go ahead and do the numbers here. I think I know these ones, so I'll probably do it. If we're leaving it in exponent form, though, this is an acceptable answer. I'm going to go ahead and do this one, though, because 4 times 4 is 16, times 4 is 64, x to the 6th. And then this one is 125 y cubed. And if they shared any like factors, we could reduce that down. But the thing is, they're not going to share any like factors because this is the prime factorization. That's a thing that we haven't talked about in a long time, though, so don't worry about that. Anyway, that one has a lot of steps, but we did get there in the end, right? So remember, let's just go through this one again because there was a lot there. The power goes to both the numerator and the denominator. So I took the numerator in parentheses and cubed it, and I took the denominator in parentheses and I cubed it. And then we had to remember our power of a power rules, which meant that this was 4 cubed and x squared cubed, and this was 5 cubed and y cubed. Then we finally did this last step of simplifying to get the x squared cubed to x to the 6th. And then just for funsies, I went ahead and did the math and got the 64 over 125. All right, let's do the last example. This is a squared to the 5th, a squared to the 5th, and b to the 5th, because the 5th power goes to both the numerator and the denominator. So this is a to the 10th over b to the 5th. And that seemed very anticlimactic after the excitement that there was in C, because D was actually significantly easier. So, hey, anticlimactic ending here. That's the end of this particular video. Go ahead and go back to your notes or Canvas and do the 4 problems that are there, and we will capture them in the last video here in just a moment. So, we'll see you in just a second.